Good afternoon, everybody, and welcome to episode 5 of the Tig series. Welcome back, guys. So I know we haven't done a TIG video in I think 3 weeks now, and for that I apologize, but the shop has been so incredibly busy with everything going on. A lot of people have time on their hands, so they're dropping their vehicles off to get things fixed, to get things repaired. So we've been cranking out the Jeeps. We got a Toyota coming, we got a Silverado coming, we got all kinds of stuff going on, plus our normal maintenance stuff. Everything has just gotten super duper crazy. We have a pretty cool project sitting outside that we'll be showing you guys in the future, but today, what we're going to go over is metal preparation, or preparing your workpiece for welding. Now, that is going to include cutting, shaping, fit up, cleaning, all of the stuff that you need to do to ensure that the TIG weld that you're spending so much time learning how to do comes out perfectly, and that you don't waste all of that knowledge welding together dirty metal, or metal that is going to cause you problems while you're welding. So what I'm going to do is I'm going to take you around the shop a little bit, or at least the little fabrication area here, and I'm going to show you all the different methods that I have here in the shop to prepare metal for welding. Alright, so the first item that we do have available to most of us, and is probably the cheapest out of everything I'm going to show you today, is your abrasive angle grinder. Now, these come in all sorts of forms, shapes, whatever. As cheap as $20 I've seen them, and as expensive as, $200 or $300 depending on what you get, whether it's cordless, corded, whatever. But you can put abrasive flap discs on this. You can put, thin cutoff wheels. You can do big, heavy-duty stone grinding wheels, all kinds of stuff. So that's going to be your step one if you're first getting into it and you need to cut metal. These cut. They don't do a very clean job of it, but they cut. The next thing on the list is a bandsaw. Now, this is a Harbor Freight bandsaw. These are relatively inexpensive, couple $100, and a bandsaw is going to offer you a ton of versatility. Just like the cutoff wheel and the angle grinder, you're going to be able to cut every single thing you can imagine on this. You can cut stainless steel, titanium, mild steel, aluminum, plastics, wood, you name it. With just a simple blade change, you can go from doing metal to wood. This happens to be a metal blade, but the versatility of a bandsaw is insane. Now, where you're going to run into problems, though, with a bandsaw is that you only have a very limited amount of space, especially with this saw, between the blade, which is right here, and the throat of the machine. So this only has about a 3-inch throat, and if you notice, we had to notch it to get a little bit more room. And because this is technically a horizontal bandsaw, and I use it as a vertical, in the horizontal fashion, it works really, really well for cutting tubing and, long pieces of lengths of steel and things of that nature. But the nice part about it is you're going to get left with a finish that is almost 100% ready to weld. So bandsaw is a must-have. All right, so next on the list is your abrasive chop saw. Now, these have been very, very popular for years and years and years, and they work really, really well for what you're doing. They use a big fat abrasive wheel to cut through whatever material you're using. However, they do have a major downfall. The cut left by this machine is not clean in any way, shape, or form. You will have to deburr it. You'll have to grind it. You're going to have to straighten it out, because I don't know if you can tell, but this blade can tend to deflect when you're cutting through larger or thicker materials. The blade will come down and then it'll start to angle, and you'll end up with slight angles. So you have to be really careful of what speed you go through with this and everything else. So Although these are great, they're very versatile. You can cut stainless, aluminum, you can cut mild steel, you can cut titanium with them, you can cut just about anything, but you're going to be limited in how well your finish comes out and how much time you're going to be spending cleaning up the cut from this abrasive wheel. And what we'll do is we're actually going to make a cut today with this machine. We're going to make a cut with the bandsaw that's back there, and we're going to make a cut with our last item that I want to show you guys. This is an Evolution chop saw, metal chop saw. And what's nice about this particular saw is that it utilizes a carbide blade, and it spins at a slower RPM. Now, the benefit of this machine here is that you can cut with this blade. I've managed to cut aluminum and mild steel with it. You cannot cut stainless with this blade. You have to get the stainless steel blade. This blade will just destroy itself with stainless, so you have to get different blades. So that is one of the downfalls of this particular machine, is that for different materials you need different blades, whereas with this machine you can literally cut anything with one abrasive wheel. However, you'll see when we make a cut with both of these, you're going to see how much better the cut quality is on this versus even the bandsaw. So we're going to set these up right now. I'm going to get some mild steel. We'll make a cut on the abrasive wheel. We'll make a cut on the metal chop saw from Evolution. And we'll make a cut on the bandsaw. And we'll show you what the differences are. Okay, so the first one we're going to cut with is our abrasive chop saw. We got a piece of 2" by 2" square stock in here. It looks like it's about 1/8 wall. And we're going to do all these cuts in real time, so you can see how long they take and what they consist of. So let's get to the chop saw. Headphone users, I apologize. Alrighty, so I don't know how long exactly that took, but here's what we're looking at. Now you can see that there's a pretty significant burr on the outside of that. You can probably still see that this part is smoking right now. And if we get a closer look at the actual piece itself, you can see there's a blue burr right there, which means that we put a ton of heat in the material. And there's another burr at the bottom. So what you're ending up with here is now you have to clean that burr out. There's another burr on the other side. There's a burr on the back side here, and there's no burr here. However, the piece we cut off is so hot that I can't touch it. But you've got a pretty big burr there. You've got a burr right here that is still super thick. So that would need to come off. So you'd need to hit that with an abrasive wheel or a grinder or whatever. And then we got some more stuff going on inside here. So although this cuts relatively quickly, that was probably what, 10 or 20 seconds to cut that, we've got a lot of cleanup to do. So that could add minutes or more to our overall production. So let's move over to the bandsaw and see how that does. All right, so we have our material clamped in the bandsaw. Ooh, that's hot. Don't touch that. And we're going to now turn the bandsaw on, drop it down, and we'll see how long this one actually takes and what we end up with for a finish. Alright, so we're at 30 seconds. You can obviously see it takes quite a bit longer than the chop saw does. We're going to go ahead and speed this up, and I'll give you guys the time at the end of it. Alright guys, that cut took just under 5 minutes. And the reason being is that we have a very fine-tooth blade in here because I cut mainly stainless steel with this. So if you're cutting thicker, mild steel, expect to add 5 minutes to each one of your cuts. But with a different blade, you'd get different results. This cut probably would have taken a minute, minute and a half maybe with an actual mild steel blade. So now you can see the cut is actually pretty nice. We do have a little bit of a burr down there, and this is the piece we cut off. You can see that there is a tad bit of a burr right there, but it is literally something that you can just whack with a file real quick and it'll come right off, as compared to the side we cut with the abrasive chop saw, where you can see a significant amount of material that you're going to need to remove all over this thing. It actually looks like you chopped it crazy. That's the bandsaw cut, much nicer. So now what we're going to do is we're going to go over to the bench again, and we're going to hit up the evolution saw and see how that does. So now we're set up in the evolution saw. Now the evolution saw claims, and I've actually witnessed it, basically claims that very little sparks, little to no burr, a cut that's completely ready to weld. And the reason being is because we're cutting it with a carbide blade instead of an abrasive wheel. We get the material out of the way quick. There's very few sparks. There's very little heat, if any, put into the material. The only downfall to this saw is that it is loud. And I mean loud to the point where if you're doing any more than 1 or 2 cuts, you're going to need hearing protection, because this thing will wake up your neighbors 1.5 miles down the road. But let's make a cut with it, see how it goes. Again, headphone users, I'm going to dumb this down a little bit, but be careful. I almost feel like we need to do that again, because this part, see how shiny and clean that is? It does have a little tiny burr that I can actually get off of here with my finger, but it is super clean, and I just want you guys to see how quickly this cuts through this material. Now you remember the bandsaw took us 5 minutes, chop saw took us about a minute, and this thing, let's let it run. All right, so what do you think? You impressed? Let's take a look at that. Now I'm holding my finger on the cut that I just made. And to prove to you that it's cold, I put my finger on that. It literally generated 0 heat. And the only burr is this little tiny guy right here. And you can literally just whack that off with your finger. That didn't sound good. You can literally just knock that off with your finger and you're good to go. You hit it with a file quick, you're good. As far as cleanliness of the cut, when you go to put this back together, the fit up is going to be damn near perfect. Like I said, a quick little shot on, you know, a file, and that'll be absolutely perfectly cut. nice and straight. It does make a ton of chips. And you do need safety glasses. Please wear safety glasses with this saw. I just had 17 pieces of metal hit me in the face and bounce off my glasses, so please make sure you're using it. But that cut is amazing. And you saw how quick that was. I don't even think that was 4 or 5 seconds that it took to get through that material when the other took us forever. So, now that we've tried all 3 of those out, let's talk a little bit. So when it comes to TIG welding, one of the most important things is how you prepare the material that you're going to be welding. Now, it's very similar to auto body work. If you put all your time and effort into the preparation, when you spray the top coat, it's going to look absolutely amazing because you took your time and made sure everything underneath the top coat is perfect. That also goes for TIG welding. TIG welding is very, very susceptible to contaminants in the metal, which we didn't talk about with the abrasive saws, with the abrasive cutoff wheels. The little grit that's in these can actually get embedded into the metal, and I don't think that it would show. Actually, it might. So right where my fingernail is on that piece, if you can see little dots in there, which you might be able to see, those little dots are actually embedded material from the sanding disc or from the cutting wheel. That material is a contaminant, and you will see it as a defect in your weld, whether it be a little bit of porosity, whether it pops and spits at you, whether you end up blowing a hole in it. You will have those contaminants generated by a flap disc, a grinding wheel, a cutoff disc, an abrasive chop saw, especially in aluminum. If you're cutting aluminum with an abrasive chop saw, you're going to fill that aluminum full of abrasive material, and then the welder or whoever's welding it, or if you're welding it, you're going to have massive problems. So the abrasive cutoff wheel, although it works when it comes to TIG welding, not the best thing to be prepping your metal with. Now, the second one that we cut with, the bandsaw. Now, the bandsaw leaves a really nice finish. That is actually the bandsaw cut right there. Does have a little bit of burr on the exterior, but again, nothing crazy. The problem with that is if you cut all sorts of different materials, like say you do aluminum, you do stainless, you do whatever, you're going to have to use either different bandsaws with different blades with different tooth counts and different material makeups, or find yourself an all-around blade that can cut all of those. However, you are going to sacrifice some speed when it comes to thicker steels. But you're not going to leave any embedded material from a cutoff wheel with the bandsaw, and you're also going to have a much straighter, much cleaner cut than you would with the abrasive cutoff wheel. Now, the final saw that we use, the Evolution metal saw, literally cuts instantaneously. And I mean, you guys can see how clean that cut is. And if we put a piece on top of it, there is zero gap whatsoever. Nothing. It is a perfect fit up. We could turn around and weld this together and grind it down, and you would never be able to tell that it was even welded because of how nicely that saw cuts and how quickly it cuts. I mean, if you're cutting mild steel or aluminum and you want speed, that saw hands down just blasts right through it. So now that we have cutting the material down, I want to go over just a couple of minutes of prepping the material before you actually lay your first arc on it. Now, material like this mild steel has what they call a mill scale on it. And every bit of mild steel that goes through any kind of a machining process to make it will have that on there. You can see it's got a welded seam right here. And then this darker material all the way around is the mill scale. And I found that whether it's hot rolled or cold rolled, it doesn't really matter. It's going to have some sort of scale on it. Now that scale is going to be a contaminant in your weld. So truthfully, what you're going to want to do at this point is take a flap disc like this and just get all of that mill scale off of there. Get down to bright, shiny metal, and your weld will be much, much easier. And then after you've gotten it down to bright, shiny metal, before you start the arc, what I'm doing right now is I am contaminating this material. And let's see if I can actually get you to see it. Maybe, maybe not. If you can see a fingerprint right there, you can also see somewhere that there's contamination, and you're going to have a fingerprint that stays in there forever. And if you look at my thumb, you can see how much crap is actually on that material. So even after you've gone ahead and ground all of the mill scale off of it, you need to use something like a little bit of acetone. One of these little squirt bottles of acetone works really, really well. You just squirt it on your material or squirt it on your microfiber or whatever you're using, you know, rough paper towel. And you just clean off the metal with some acetone. And you can see we got quite a bit off of there. And although that looks better, we still got mill scale on it. So grind off the mill scale, hit it with some acetone, and then you're golden. So that's mild steel. Stainless steel is actually a whole lot easier to work with because, for the most part, it's already clean. Doesn't have any mill scale on it, doesn't have any of that crap on it. But one of the prep issues with stainless steel that I'm going to stress with you guys is if I roll this, you're going to see a lot of fingerprints on it. Now, if I weld on this material with these fingerprints on it, the heat is going to lock that fingerprint into the stainless steel. So that is one super important thing when you're prepping stainless steel, is once you've taken your acetone and you've cleaned off your stainless and you've gotten your fingerprints off of it, you do not want to touch it again. Because even though my hands look dry as hell, if I touch this, I can put tons of fingerprints right in it. And then if you weld it and heat it up, those fingerprints are going to burn right in it. So in stainless steel, super important. Clean all the contaminants and your fingerprints and everything off of it with acetone. Do not touch it again without gloves on, and then you can weld it. Now, aluminum, this stuff here, has its own protective oxide layer that stops the aluminum itself from oxidizing. However, when you start to weld it, the welder breaks through that oxidation, moves it out of the way, and then welds it. So what you're going to have to do with aluminum is literally a little bit of acetone, a little bit of elbow grease, and then you're ready to weld. Same thing. Don't want fingerprints, you don't want dirt. Sharpie marker, Sharpie marks are definitely going to cause you an issue, so you want to get those off of there. And just make sure overall that your metal's clean, that you don't have any contaminants in the actual metal itself. So don't cut aluminum with an abrasive chop saw because it will get contaminated heavily and you'll have such a hard time welding it. Alright guys, so we're going to say one more quick thing about your preparation of your metal is fit up. That is the last thing we're going to go over today, is how the metal fits together. And you've heard me say it throughout the entire video that making a cut that is as straight as possible is going to allow your material to fit up as perfectly as possible and give you the best possible weld. Now, yes, you can fill gaps with TIG welding. It's not the easiest thing in the world. And it's also not the best thing to do when you're trying to weld two pieces of metal together. So fit up is ultra important. It is just as important as your cleanliness, because your weld quality, your weld ease is going to be significantly impacted by how much of a gap, how bad your fit up is. And if you're building something like an exhaust system or you're building anything that's long, any little deviation in a cut at the beginning translates into a large area at the end. So if you're off by 1/8 of an inch in the beginning, you might be off by 2 inches at the other end because your cut's crooked. So you have to be very, very careful with how things fit up. Having the straightest possible cut with the best possible finish is going to give you the best weld when it comes to TIG welding. Alright guys, so I wanted to get that out of the way so that we can continue on welding. You now know that your cut is important. You now know what tools you can use, what tools you can't use, what tools are better for certain materials than others, and hopefully you gained a little bit of knowledge and you'll be able to better serve yourself when it comes to learning how to TIG weld by first preparing your materials to weld so that you're not scrambling trying to figure out how to weld something that doesn't fit up properly and you give up and you fail. So, material preparation, super, super important. And on that note, before I continue babbling for another 20 minutes, I'm going to move on and do a bunch of other stuff that I have to do today. And what we're going to do is I'm going to try to come up with what we're going to do next for episode 6. But thank you guys so much for watching. I hope you learned something. I hope it helped you out, and keep TIG welding. I will see you guys on the next one. Have a great day.